Hello everyone, in this video we are going to understand how to calculate the power of large uh, numbers. For example, if I have to calculate power of 2 raised power 42, it will be very large for computation. Let's see what I mean by very large here. So if I have to calculate the power of let's say 2 raised power 7 here, okay, so 2 raised power 7 is 128 that we know, and let's see how to calculate that through a program. So I'm going to simply write a for loop, and it will be iterate from I is equals to 1 to I less than equals to 7, I plus plus, and my result, which was, let's initialize result as 1, result will be A multiplied by result and return result. Okay, so this is how we are going to calculate the power through a normal iterative way, and the time complexity will be order of n, where n is the power here. Okay, so how, let's dry run on 2 raised power 7 only. Okay, so what it is going to do, I is equals to 1, result will be and A is 2 here, so result will be A multiplied by 1, which is 2. I is equals to 2, result is 2. What was my A here? 2 again, result again is 2 raised power 2 or 4. I is 3, result will be 2 raised power 2 into, what was my A? 2 into what was my result? Result was 2 raised power 2, so it is 2 raised power 3, which is 8. I is equals to 4, result is what is my A? 2. What is my result? Here it is 2 raised power 3, 2 raised power 3, 2 raised power 4, which is 16. I 5, result is 2 raised power, what is my A? 2 into 2 raised power 4 to 5, which is 32. I 6, result is 2 into 2 raised power 5, 2 raised power 6, which is what? 64. I is equals to 7, result will be A multiplied by the previous result, which was 2 raised power 6, which is 2 raised power 7, which is 128. So how many times we are iterating? So we are iterating the number of times we have to calculate the power, which is 7 times here. So that is why the time complexity is order of n. Okay, can we optimize it? Yes, we can optimize it. We can optimize it to the same thing can be, we can get the result in iterating 3 times only, performing the calculation only 3 times we can get the result. How? And what I mean by 3 times, it will be log of n. So log of the base to the power 2 of 7 is 3, somewhere around 3 point something, so it is 3. So we will have to iterate or perform operations only 3 times. So how the optimized version we can implement in 2 ways. First is recursion, second is iterative way. The main intent of me recording this video is that I have found a lot of videos explaining pretty well the recursive way of implementing this optimized approach, but I have found even I've watched one, but I've found no video explaining the iterative way that beautifully. So this is my attempt of explaining where I have spent a lot of my time. So yeah, so first we'll understand what is that optimized way. So we have to evaluate. Let's take the same example as 2 raised power 7. So if I have to evaluate this, can I write it like this? 2 raised power 3 into 2 raised power 3 into 2 raised power 1. What is that? Why I'm writing this in this way? So if you know if the base is sum in the multiplication, the power adds up. So here the base is same for all three. The power on adding will be 3 plus 3 plus 1 is 7. And 7 divided by 2 is at what? 3. So if I have to split it into 2, I'll simply divide it by 2. And what will I get? I'll get 3. So by splitting it into 2, I'll have to divide it into 3 into 3. And then on dividing it into 3 into 3, the sum will be 7, 1 less than the original. So that is why I have added 2 raised to power 1 here. Okay, again 2 raised to power 3 will be 3 by 2 is 1. So it has to be split into 2 raised to power 1 into 2 raised to power 1 into, again 1 plus 1 is 2. I'm still 1 less than the original, which is 3. So again 2 raised to power 1. Okay, 2. Anything raised to the power 1 is actually itself. So it is this. Okay, so yeah, so 2 raised to power 1 has returned 2 actually. So how many times we are doing it? We are doing it this many times. Okay, no, actually log of 7 is 2. Okay, somewhere around 2 point something actually. So yeah, so only 2 iterations we have to do instead of 7 iterations. Yeah, so what we have seen here, if we are splitting the power into 2, I'm splitting the power into 2 raised to power 3, 2 raised to power 3 and 2 raised to power 1. Calculating the result of this and this will be like, again, why do I have to do the calculation of this again if I have got the result of 2 raised to power 3? So I can utilize this intuition. So here I am going to again split it into 2 and calculate the answer for this only. Here again calculate the answer for this. I have got the answer for this as 2. So I am going to multiply it as, I have got the answer as 2. I am not going to evaluate the answer for this. I am relying on what I have got from this because these two are same. Into 2 is 8. Here what? I have got the answer of this 2 raised to power 3 is 8. I will not again perform the calculation for this, and this will be saved because this and this is same. So 8 into 2 is actually what? 128. So this is how I have to calculate this is how we are calculating and optimizing the solution. Let's implement it in recursive way. So what I have explained right now, I'm going to try implementing it in recursive way is int power int a int p, and what I'm going to do, half power long, let's say the nature is long, and I'm going to call the same function again and the same function on the half power. Okay, the full power will be whatever I have got from here. I'll be relying on that only, and I'm not going to perform the calculation again. Okay, now if you have remembered, I was multiplying by itself in case of it was odd. I have explained you why. So if my power mod 2 is 1, which is odd, what I am going to do, I am going to multiply power with itself a, and here I am going to return result. This is it, the function, but we are missing something. We are missing the exit statement. If p is equals to 1, return a. Okay, complete function. Let's write one edge case also. If p is equals to 0, return 1. Okay, why? Because anything raised to the power 0 is 1. This is the recursive function. Let's see the iterative approach. The iterative approach is, the explanation of iterative approach is a little different here. So here 2 raised power 7 can be split into 2 raised power 4 into 2 raised power 3. Okay. And this 2 raised power 3 will take care of this later. Let's see how to calculate this 2 raised power 4. 2 raised power 4 will be 2 raised power 2 into 2 raised power 2. 2 raised power 2 will be 2 raised to power 1, and it will be 2. Okay, makes sense? So here this, it can be split into this. So I am calculating this, and I'll get the result in 2 iterations. Okay, so yeah, so the intuition behind this is is that split whatever the power is into the a raised to power closest power to p multiplied by p a power remaining. So if I am going to let's see or write whatever I have explained here, okay, through the code here. So it is going to be int power, and then we'll perform dry run and understand that. Int a, int p, again the same thing here. Let's say int result is equals to 1, and we are implementing it through iterative, so while loop. We'll do as long as the power is greater than 0. Okay, and we are going to do what? We are going to do here, we are performing how many times? 2 times. What? A multiplied by a itself, 2 multiplied by 2, whatever we have got, and then we are multiplying 2 by 2 multiplied by 2 raised power 2, and we'll get 2 raised power 4. Okay, the power will be split into half. Okay, and this is it. But what about the result? So the result is, if my power is odd, I'll simply result will be result multiplied by a, and this is how I'll get the result. Yeah, let's so this is the logic here that I have explained you here, and this is result is storing the extra part, and a, which is the closest power of 2 to my given power, is maintained by a here. Okay, so let's perform dry run on 2 raised power 7 here. Okay, so 2 raised power 7 is what? Result is 1, power is what? P is 7, okay, and A is 2 here. Okay, and so yeah, result is 1, P is 7 here, A is 2 here. So P is greater than 0, yes. 7 is greater than 0, yes. Is P, which is 7, mod 2 is equals to 1, P is 7 is odd, yes, it is odd. So my result will be 1 multiplied by A, which was 2 raised by 1. Okay, my A will become 2 into 2 is 2 raised by 2, and P will become half, 7 by 2, which is 3. 3 is greater than 0, yes. Again we are going to do, we'll enter in the while loop. Is 3 mod by 2 1, which is 3 is odd, yes, it is odd. So the result will be 2 raised power 1, which was my earlier result, into what I have received the new A, 2 raised power 2, which is 2 raised power 3. Okay, now A will become as 2 raised power 2 multiplied by itself, 2 raised power 4, and P will be 3 by 2 is 1. Okay, and then what I'm going to do, again we'll enter the while loop. Why? Because 1 is greater than 0, yes. Is 1 mod 2 is 1? Is 1 odd? Yes, it is odd. So the result will be 2 raised to power 3, the old result, multiplied by the new a, which is 2 raised to power 4, which is 2 raised to power 7. Okay, and p will, the new a will be 2 raised to power 4 into 2 raised to power 4, 2 raised to power 8. P will be 1 by 2 is 0. 0 greater than 0? No. So the result is 2 raised to power 7. So here we are actually doing a little different the iterative way. We are splitting nearest power. So if it is 2 raised to power 15, we have to calculate. So it will be, the nearest power will be 2, 8, 6. Nearest power, the power of 2 will be 2, 8. 2, 4, 8, 16, 32, 64, and so on. The nearest power 15 is less than what? 16. Nearest is 16 here. So here it is. The nearest is the less than, the power less than the maximum power of 2, which is less than, here 15 is 8 here. So it will be 2 raised to power 15 will be split into 2 raised to power 8 into 2 raised to power 7. If you are going to perform do dry run on this is what we are going to get. So this is how the iterative approach is implemented, a little different from what we have seen here in the recursive way. So yeah, this is all about the iterative and recursive approach of calculating the large powers. Hope this would help, and because it took me a lot of time understanding the iterative way. So yes, thank you very much.